Hi everybody, this is Jeff here with Room to Discover, and I'm very excited to be putting together my first online course. It's a course on how to transition to Common Core mathematics with a focus on elementary and middle grades. I think creating something for Common Core transition is really important. Most of us went to school at a time when math was about decimals, fractions, multiplying, doing everything with traditional algorithms. And nowadays there's a need for more conceptual mathematics. Most of the work that's done in the real world with math nowadays does not revolve around algorithms. That can be done by computers, by calculators. What we really need are people who can understand mathematical concepts and who can apply an understanding of math to the real world. And that's basically the main focus of Common Core math. In today's preview, I'd like to focus in on visual models because visual models are a central part of the Common Core shift in math. The reason we use visual models is that they help students develop numeracy, which is an understanding of the meaning of numbers, and also an understanding of the meaning of operations like addition, subtraction, multiplication, division. It's no longer enough to just be able to perform these things. They actually need to know what they mean, and when we use them, visual models are a great way to help develop that understanding. Visual models also help differentiate learning so that students have multiple pathways. If you're explaining something to them, or they're seeing stuff done in algorithms, mathematical annotation, and this is just another pathway to understanding. It also helps students develop mental math skills because when they have a conceptual understanding of numbers, they can think more flexibly about them and use some creative problem-solving strategies. So the one thing that I have noticed is a big challenge with visual models is that we tend to introduce visual models at a certain grade level, regardless of whether the students have developed the foundations for that. And if you think about the typical progression that we are now teaching kids with mathematics, we start with manipulatives, right? Physical objects to get an understanding of numbers. That can be counters, blocks, things like that. And then we move to pictorial representation. That's what I'm going to focus on today, is our pictorial representations. And then we use that as a foundation to develop algorithms. And basically the most abstract part of math, which is writing things like 3 times 7 equals 21, or 3 to the 4th over 17 equals x squared. That's the annotations, the most abstract part. But even within visual models, there are several levels of abstraction. And let me show you what I mean by that. So if we were to draw a picture of 3 circles, right, this is very close to a physical representation. You can imagine 3 blueberries, 3 counters, anything like that. So this would be a pretty basic level of visual model because it's a lot like a physical object, and we're counting to 3. I might also then draw 2 more, and this is now a representation of a number sentence, right? 3 plus 2 equals 5. And nothing too complicated yet, but this is starting to build foundations. One thing that I can demonstrate with this is that when we count up from 3 plus 2, just thinking about the fact that adding is really just counting, and counting is a foundation for adding. Subtraction is the opposite. So if we just cross these things out, we started with 5, we took away 2, and we had 3 left. So now we've used these counters to get the concept of what's addition, what's subtraction, the fact that they're opposites. Now the next level I would go from here is to then arrange these into rows. So if I have 3 counters here and I were to make another row of 3 below them, okay, now I've created 2 groups of 3, which we'll recognize as the number sentence. 2 times 3 equals 6. We can also show that that is repeated addition, right? We had 3 and we added 3 more. And then we can also bring a foundation to division, which is the opposite of multiplication, the opposite of repeated addition, also known as repeated subtraction. So we have 6 things, we split them into 2 groups, and each group has 3 in it. Now, being able to do this lays the foundation for all kinds of future visual models. For example, an area model, you might have something like 13 times 27, right? And so what I might do is think about, okay, here's a group of 10, here's 3, here's 20, and here's 7. And I try to make them somewhat to scale. As you can see, this is not twice as big as that one, but it gives me some idea. And I like to show kids that now we can, we could do this as one big box, 13 times 27, or we could show them that, 10 times 20 is 200, 3 times 20 is 60, 10 times 7 is 70, 3 times 7 is 21. And if we add all these up, we're going to get the same thing as 13 times 27. So 260, 330, 351. And for me, I find that easier than stacking things and carrying the 1 and all that, where you might get lost on the space of it. It also provides a great foundation, and you can see here that in geometry we're going to start teaching kids the idea of area, that 3 times 2. So you kind of get a little bonus that not only does it make it help them with multiplication, help them with the idea. This is actually providing a foundation for what's called the distributive property that they're going to do later on, that if I multiply 13 times 27, it's the same thing as 10 times 20 plus 3 times 20 plus 10 times 20 plus 3 times 20 plus 10 times 7 plus 3 times 7. Some people refer to that as foiling. So if you, and this is going to be something that they're going to use in algebra to, to distribute one number that's multiplied across several numbers that are inside parentheses, things like that. So we create these conceptual foundations, and then when they get to those higher level concepts, it's a very smooth transition instead of having something totally out of the blue that they haven't thought of before. But another thing that I like about these area models is it's really useful when kids start getting to fractions. And this is one place that we've probably all seen some sort of area model, where, to get the understanding, what does 1/2 mean? I, cut something. Kids tend to have a pretty natural understanding of half because we use that in common language. But then when we get to things that are slightly more complicated, like a third, you see a lot of misconceptions where kids just don't understand what the meaning of 1/3 is. So being able to do that is helpful, especially operations with fractions. So if I wanted to do 1/3 plus 1/3, kids will come up with all kinds of things. 1/3 plus 1/3, you'll see things like 2/6 and things like that, or they just don't know where to start. But if they actually realize, oh, this is 1/3, and they've developed this understanding of what addition means, is that we're counting up by one more third, then it becomes very intuitive, and they can make that transition to adding fractions, multiplying fractions. One more level of abstraction, in my opinion, is the number line. It's a little more abstract than array, maybe equally abstract as an area model. And number lines can show us distances between whole numbers. We can see that, if I have 2 and I add 3, I can start here at 2, and then I count up by 3, and by the same token we can count down, or we can show distances, right? So like 5 take away 3 is going to get me to 2, or we could say 5 take away 2, the distance between those two is 3. So we create all kinds of concepts of numbers. And then when we get to number lines, that also provides a foundation for what they're going to get a little bit later in middle school, where we have two number lines perpendicular to each other, also known as the XY graph. And if you have a solid foundation in thinking of, this is 3 and this is 2, the idea that we would call this point 3, 2, and that we're representing two numbers with one point is much simpler. So when we try to teach kids something as abstract as this without these foundations, or trying to teach kids area by memorizing, oh, well, what if I wanted to do 1/3 times 1/2? Well, that's 1/2 of a group, right? Because multiplication is groups of things. 1/2 of 1/3, and I can see that now I have 6 total pieces. One is contained in both the tan and the blue areas, so it makes sense that 1/2 times 1/3 is 1/6, and that sense making, again, is really what these visual models are all about. So I hope this overview it gives you a sense of why visual models are important. This is not the be-all and end-all, and when the course is complete, we're going to have a full module on visual models and really get into how do we progress from one to the next, how do we develop that operational understanding. If you have any questions, comments, anything that you really would like to see in the course, or any suggestions, I'd love to hear them. Jeff@roomtodiscover.com, or you can visit the blog roomtodiscover.com and check out what I've written. I do welcome all kinds of comments and suggestions. So keep your eyes out for the course,